Okay, so yesterday we talked about single replacement where metals were replacing metals, and we had that activity series. Okay. The higher on the list would replace lower on the list. Seniors never end up dancing alone. So that's about metals, not about metals, but non-metals can also replace non-metals. Non-metals can replace other non-metals. Now, first of all, there's a lot fewer of them. Non-metals are up in the upper right-hand corner. So there's only going to be few non-metals. And we're not even going to talk about all of the non-metals. We're actually going to limit ourselves to the halogens. Halogens, group 7A. And with those, I don't have to give you a separate activity series, because the activity series is the same as the order on the table. Fluorine's at the top, iodine's at the bottom. So fluorine's the senior, iodine's the freshman. F can replace everything, I gets replaced by everything. And it actually ties, AT's too rare, we're never going to see it. Okay. The big clue about that is it's got parentheses here, which means it doesn't exist in nature to any degree. Okay. So that's the order. It's about electronegativity. Because if you think about it, when you're doing single replacement, you take something, one doesn't have a charge, the other does. And they swap places. Here the calcium didn't have a charge, here it does. That means it gave away electrons. Hydrogen had a charge, now it doesn't. That means it picked up those electrons. So single replacement is really about who's pulling the electrons. Okay? And fluorine pulls the electrons more. Had the highest electronegativity, so it pulls the electrons most, so it ends up with the electrons, it ends up neutral. So single replacement is really about a fight for electrons. And the one that's more active pulls those for here pulls the electrons more. So higher on the list replaces lower on the list. So if I were to bubble F2 into some HCl and have to bubble it because it's a gas, first of all, I have to recognize that it's single replacement. And I can tell it's single replacement because it's got an element and a compound. Okay, once I figured out that it's single replacement, then I'm going to do that. Fluorine is going to replace fluorine. So H is going to not end up next to Cl. H is going to end up next to F. Because things that are like each other can replace each other. Positive pieces can replace positive, negative can replace negative. Okay? And the H gets kicked off by itself. And I know this is going to happen because F is higher than Cl. So I did what the name said. Now I need to figure out subscripts. So Cl, yeah, Cl, sorry. I don't know why. So you spread HF. So HF plus Cl. Now I got to think about subscripts. Cl needs a 2, H is 1 plus, F is 1 minus. That's okay. And then I just have to balance it. I got 2 F's, so I put a 2 in front of HF. That gives me 2 H's, so I put a 2 in front of HCl. That gives me 2 Cl's, which I wanted anyway. So it's the same process. Do what the name says, single replace. Replace things that are like each other. Okay, check to see if they're going to replace. See which one's higher, which one's lower. Okay? And if they do that, then figure out subscripts, then balance. Okay. So you can put Cl2 plus 2HF is fine. Okay, so this plus sign, remember, is the word and. So green and red is the same as red and green. Make sense? It's commutative. Ooh, keep using that word. Commutative. Okay. Bromine plus KCl. So element and compound tells me it's single replacement. Bromine is a non-metal, so it's going to replace Cl, the non-metal. Can bromine replace chlorine? Bromine is below chlorine, so this is no reaction. Because bromine is below chlorine. On the periodic table. Right? So here's an example of the other ones we can do. Okay. Just work through a couple more examples before I give you practice for you to work on them. Okay, so here's because we didn't do very many last time, so we've got the basics. Now we're going to work on getting them. So Li plus HCl. Li is a metal. Okay. On this side of the zigzag line, so it's going to replace the metal part. The metal part of HCl is the H part. And lithium replace hydrogen. Lithium's at the very top of the list, so it can replace hydrogen all the time, no matter what it's next to. Right? So lithium is going to end up next to Cl, and H is going to be by itself. Lithium is in the 1 plus column. Cl is in the 1 minus column. So 1 plus and 1 minus. It's just LiCl. Can H be by itself? No. And then down. Because I put that 2 next to H, I've got to put a 2 in front of HCl, which gives me 2 Cl, so I've got to put a 2 in front of LiCl, which gives me 2 Lis. That's 2 in front of Li. Okay, well, we got lithium plus water, and we just said lithium always replaces hydrogen, even if it's with water. So lithium, and here's the tricky part. I don't want to think of water as H2O. I want to think of it as HOH. Because it's only going to replace one of the H's. So Li is going to end up next to OH. And H will be by itself. Okay, so it did this. It's like, so I think of it as hydrogen hydroxide, and only replaces the hydrogen part of hydrogen hydroxide. Okay, lithium's 1 plus, OH is 1 minus, so that's okay. H can H be by itself, let's get to 2. So now I've got 2 H's, already had 2 H's. So I got 3 H's, 3 H's. The lithiums are okay, 2 lithium, lithium on each side, and oxygen on each side. So I got to fix those H's, and it's 2 on one side and 3 on the other. The way we solve that is to double the first one. By doing that, that gives me 2 Li, so I put a 2 in front of LiOH. That gives me 2 O's, so I put a 2 in front of HOH. That gives me 4 H's on my reactant side, and I have 4 H's on my product side. So it's down. One last to do. NABr plus Cl2. Okay. So first I got to recognize that it's single replacement. The compound in an element. One of each. That's single replacement. So the element, Cl2, is going to replace the one that's like it, which is Br. Can Cl replace Br? The one by itself, Cl, is higher than Br, so this reaction is going to happen. So Na is not going to be next to Br, Na is going to be next to Cl. Br will be by itself. Na is 1 plus, Cl is 1 minus, so that's okay. Br needs a 2. And then down. So 2 Brs, which means I put 2 next to NaBr, which gives me 2 Nas. So I put a 2 next to NaCl, which gives me 2 Cls. I wanted anyway. So get a feel for the process. Do what the name says. Then figure out the subscripts. Then balance. Okay, so on practice number 4. It's got 2 sides. The first side is all single replacement. My activity series, I gave you a bigger activity series, but it works like the other one. Okay. Bigger activity series. On the back, I've got them mixed together. So there's some single replacement, some combination, some decomposition. So first decide which one it is, and then do that. Okay? So that's what's going on here. So the front side's all single replacement, the back side's got a mixture of the 3. Because that's part of the decision making, is you have to decide what kind it is. But single replacement is an element in a compound. The decomposition is 1 compound. The combination is 2 elements. Sometimes the answer will be no reaction.